First key concept we need to talk about is aspect angle. Aspect is expressed in degrees off the tail of the reference aircraft, commonly expressed in multiple of tens. Here in Blender, I've set up a T6 model with a protractor to discuss aspect. We'll start by going to the tail of the aircraft. Here we are at a 0 aspect. As we change our degrees off the tail, we see that the picture of the aircraft changes. And right here we are about a 10 aspect or a 1. IPs will commonly refer to these as single digits, so 1, 2, 3. However, I like to talk to them as 10, 20, 30. So for the remainder of this video, that can be used interchangeably. Right here we are at 10 aspect, 20 aspect, 30 aspect. Common visual signal you'll see, or visual cue, is this tail bisecting the wing here. 40 aspect, 45 aspect. Also is the tail touching the tip of the wing with, and also is where we talk about the star in the saddle here. If we were to look right there, that's what they're talking about. It's more apparent when we're at a 30-degree bank, which we'll get to in a little bit. Right now, this is in the same plane as us. So this would be like a root position almost. We're slightly above root, but just for the discussion, we're just talking about the degrees off for now. 50 aspect, 60, 70, 80, 90, 90 also known as line abreast. As we increase our aspect, the 90 to 180 aspects are not ones we commonly talk about, as it's a situation you shouldn't really find yourself in. Another important part about aspect is it's a right and a left, so we can think about this as a 45 right aspect, and over here would be our 45 left aspect. Aspect does not change with distance or bank of the aircraft. If I were to zoom out here, if we start here at a 45 aspect roughly, and I zoom out, still at a 45 aspect, still at a 45, still at a 45. As long as I can see the plane and identify the aspect, I know where I am at. Likewise, if we were to change the bank of the plane and say rotate it into a 30-degree bank right turn, rotate this with it, we can see that our aspect also remains the same, like we talked about. Here's our 45 aspect. We have the tail roughly touching the tip of the wing. This is kind of the picture you'll be looking for on a turning rejoin. Also, the star in the saddle right here, with lead doing a 30-degree bank turning rejoin. A 30-degree bank turn to facilitate the rejoin. If I see that aspect increasing, right, your IP will refer to the aspect is increasing. We will see that tail start to separate from the wing as we approach 60, 70, 80, and then push the 3-9 line. Likewise, if your IP is talking about the aspect is collapsing, that would mean the tail is moving towards the fuselage. So here's a normal rejoin, 45, star in the saddle. There's our 30, which is kind of the inner limit of where we want to do a turning rejoin. As we see it collapse, we see that tail start to move towards the fuselage as we move back. Aspect is a fundamental concept you must understand to talk to formation. An IP cannot effectively coach you in anything for formation if you do not understand what aspect is. This is how I instruct students in the air, and this is what all students need to know before even hitting their dollar ride. It is covered in the 11-248 chapter 9, 9.2, which is the fundamentals to form, and also in the form CBTs. Next we will be talking about plane of motion. The second concept that is crucial to understanding formation is plane of motion, which is the plane containing the aircraft's flight path. In a level turn, the aircraft's plane of motion is parallel to the ground regardless of bank angle. In a loop, the plane of motion is perpendicular to the ground. Here, I have a T6 modeled in Blender on a two-dimensional plane that is red. to visualize what the plane of motion is. Currently, we can think of the aircraft as in level flight with its plane of motion parallel to the ground. We can see that if the aircraft were to make a left-hand turn here, I am unable to animate it, but we can imagine that this plane is going to start traversing that blue line, and we'll have to enter about 30 or so degree bank turn. The plane of motion does not change. The aircraft is still in level flight, and its flight path is still on this level plane. So if we're going to continue this example, we'll put a second plane out here. This aircraft is in the same plane of motion as lead here, regardless of how far away they are. So we can move them all the way back here. They are still in the same plane. I can move them up, and all of a sudden they are no longer in the same plane. There are two separate planes happening here of motion. Continue this example. We'll say that this aircraft is going to start a loop. As the aircraft begins to pitch up, the plane of motion begins to change. Imagine this aircraft is moving through space as it's pitching up. The blue represents kind of a global plane parallel to the ground, or the ground itself, however you want to think about it. And as the aircraft rotates, as it begins its loop, its plane of motion changes. We'll raise it a little bit here to help demonstrate. As it does its loop, its plane of motion changes. So we will then go ahead and duplicate this guy and show. Right now, these aircraft are not in the same plane of motion. This is kind of something you might find yourself in ET, where an IP may say, get in plane of motion. What an IP is saying is, I need you to maneuver the aircraft to get on the same plane as the other aircraft of motion. This plane is changing as it goes over the loop, and we need to match them. So it would look like this. We'll return to level flight here. And it's kind of a brief discussion on plane of motion. Next, we'll discuss heading crossing angle. Heading crossing angle is the angular difference between the longitudinal axis of two aircraft. Heading crossing angle is crucial to being able to understand lead and lag and fly a meaningful formation as two. As an IP, I cannot have a meaningful discussion with the student if we do not understand the concept of heading crossing angle, specifically about lead and lag and more advanced concepts such as ET. To begin, we start with two T6s roughly in the root position of beam one another. Right now, there is no heading crossing angle. The longitudinal difference, as represented by these orange lines, are parallel to one another. There is zero cross occurring. However, if number 2 begins bidding in to lead, we see that the heading crossing angle begins to increase. I don't expect students to know what the exact heading crossing angle is. More so, the protractor is here as proof of concept. We see that right now we have a 35-degree heading crossing angle. As number 2 pulls more and more towards lead, we see that that heading crossing angle increases. We're now at a 60. If we point right towards perpendicular to his flight path, we will see that it increases to a full 90. What I need from a student to understand with heading crossing angle is what it means when I say increase it and decrease it. Or when I'm saying that happened because we had too much heading crossing angle, or we were really slow to rejoin because we never fixed the heading crossing angle. I need you to understand what it means when an IP tells you that. It is important to note that heading crossing angle does not mean you will meet the other aircraft in flight path. It is purely crossing longitudinal axis. This aircraft could be all the way over here, and our heading crossing angle did not change because of the longitudinal axis angular difference did not change. Even though if this aircraft continues flying forward, our flight paths we will not hit each other. There will be no collision, but we still have heading crossing angle. Another important concept as we talk to lead and lag is that we see that as we increase our heading crossing angle towards 90, aka taking a bite of a bite of lag, our heading crossing angle increases. Similarly, as I pull lead, our heading crossing angle will decrease and eventually approach 0. The next key concept we need to understand is line of sight. Line of sight is a straight line from the pilot's eyes to another aircraft, commonly expressed as forward line of sight or aft line of sight. To demonstrate this, we have our lead aircraft. We'll imagine that we are viewing this other aircraft from our canopy. If this aircraft begins moving forward, that is referred to as a forward line of sight. If the aircraft begins moving aft in our canopy, that is an aft line of sight. Line of sight can occur at any orientation. It's fine if the aircraft is here, and this would be a forward line of sight, an aft line of sight. And then if it's just stationary, no line of sight. Line of sight is critical for instructors to be able to tell students how a rejoin is going, specifically like a straight ahead rejoin or an overshoot, because we need good line of sight. And that brings us into our next point, the line of sight rate, which is the speed at which the forward or aft line of sight is occurring, expressed with adjectives rather than measurement. For example, rapid aft line of sight, slow forward line of sight. So, for example, I will show you a rapid aft line of sight. If I saw that happening in my windscreen, what I would describe as an aft line of sight versus a slow line of sight. A slow aft line of sight would be something like this. The plane just barely moving aft in the canopy. Inversely, a rapid forward line of sight would be that. A slow forward line of sight would be something slightly slower. It is all expressed in relative terms. We do not have the ability to determine the exact airspeed of the other aircraft in our T6, and it is something that we must judge as pilots. What is the rate of the line of sight of the other aircraft. Where a line of sight becomes really important is for straight ahead rejoins, is a common example. If I make my bid out and I am seeing the other aircraft move rapidly back in my canopy as I am moving into to stabilize in a route position with 0 heading crossing angle, that means I need to do something. I need to pull power. I need to slow that line of sight so that I do not overshoot. Likewise, on a overshoot, let's say I did a turning rejoin and I overshot and I've stabilized en route echelon over here, I cannot move to the inside of this turn until I begin seeing the other aircraft move forward in my canopy and establish forward line of sight. If the lead aircraft is moving aft in my canopy and I attempt to move in, it risks a second overshoot or worse, going completely blind because the other aircraft gets behind you.